Hi, welcome to your Math Resource Showcase. I'm Amber Soto, and this week we've been focusing on that beautiful place where math and art come together. I posed a challenge to you from ucubed.org, which is the Joe Bowler page that we've seen many times before. Normally I would go back to the page, but I actually created a video so you could see the process of something that I built to better understand the problem. But I thought it was important that you remembered it's youcubed.org. ucubed.org is where we came up with this. There's a tab under tasks that says maths and art. So you can look there to find this project and more if you're interested in recreating or seeing how it was done. But with that said, I wanted to share this video with you. Now, a quick little disclaimer, there's certain parts where the audio was a little funky, so we just took it out. And so I'm gonna count on different spots and interject my thoughts there. So here we go.
Okay, so when we are analyzing these structures to try to break them down, there's a couple things we want to notice at first. The first thing I notice here is that it counts up
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12.
The other thing I notice is that it goes outward.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And it also counts the other way, all the way up through to 12.
So when we're building it, it looks like it always starts with one square. I would say one square is probably case 1. And then 2 squares would be to add 1 on all sides. Okay. I also notice over here on the side that it goes up
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I want to point out really quickly that on this one, it actually slopes back, which is why the numbers are getting smaller and smaller at the top, where this one comes straight up and down. It's a vertical. That's important to notice. If you see on this one, the front that we're looking at here is this, straight up and down, where the side that we're looking at here slopes back. It kind of stair steps up.
And you notice that behind it, it splits into 2 boxes behind the 1, and then 3 boxes behind the 2, and 4 boxes behind the 3, and so on and so forth. So always the next row back is 1 more block than the 2 initially. So we can kind of see this happen from this side too. So it looks like if we were going to build our structure, we would start kind of with the front, and then I think this side would naturally happen because it would bring the background to it. All right, so let's try building some of these structures from.
And another thing that I want to talk about that I didn't analyze at the time before I built it, and now that I have built it, I think it's important to note. I didn't even touch this third picture, and I think the third picture is actually the most important. If you notice here, this thing in the middle kind of looks like a giant 12 by 12 square, doesn't it? If you counted back, it'd be 12 this way, all the way back, and then it'd be 12 straight up and down. Then on its side, this is an 11 by 11. And then next to that, a 10 by 10, and then a 9 by 9, 8 by 8, 7 by 7, 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2, and a 1. Same thing on the other side. So it looks like there's one giant rectangle in the middle, and then just smaller rectangles work their way out. That's going to be important. You'll see why very soon in the video.
Here, now that we've done our noticings. And notice that the challenge says, if this was case 12 of a pattern, what does case 3 look like? Well, it goes 12 in all directions, so my assumption would be that it would go 3 in all directions. And then if you modeled case 3 using toothpicks and dots as connectors, how many dots would you need? What about for any case of the structure? What are the instructions LeWitt could have left for someone else to build a structure like this of any size? Okay, so I'm gonna go get my toothpicks and my dots and let's play with this.
And at this point, I speed it up because I didn't want to take too long in this video, but I wanted you to see the process that happened to get where we get. Okay, and then at this point, I'm going to jump in. You're going to see in a little bit. But what I do is I take these structures now that I've built, and I'm going to do it a case by case, starting with case 1 and working my way up to case 3. So I wanted to kind of break that down for you. So here's case 1.
What would case 1 look like? Well, here it is. Case 1 would simply be one box, 1 by 1 by 1 cube. Now we use dots and toothpicks to hold these together. So in the questions it asked how many toothpicks and how many dots. Well, we can see here that if we count the toothpicks around this top square, there's 4. And if we count around the bottom square, there's also 4. And then if we count each of the legs, there's 4. So there are 12 toothpicks in total. And the dots, there are 1 at each corner. So there's 4 on top and 4 on bottom, which is 8. So by the 1 by 1 by 1 cube case, there are 12 toothpicks and 8 dots. Well, if we were going to go 2 by 2, or not 2 by 2, sorry, case 2, then we would need to bring a 2 by 2 by 2 cube into it.
Okay, I'm going to pause it again. You'll hear me say this several times, and it makes me cringe every time because it's incorrect. This is not a 2 by 2 by 2 because it doesn't go 2 deep. It's 2 up and 2 across, but it's still only 1 deep. So really, this is just case 2. I do it several times. I do it with a 3 by 3 by 3, which is just case 3. And really, again, it's only 3 by 3 because it's only 1 deep. So I apologize for that.
But if you remember from looking at the artwork, what they ended up doing on the side is layering it like this so that it goes behind perfectly evenly. But if you look at it from the front end, there's just as many to the right side as there are to the left side. So if I turn this for you and you see it from this end, you can see how it looks like the front now, where it could go up 2 for the case 2, and then over 2 this way and over 2 this way. So again, if we look at this, we know that there's 12 toothpicks and 8 dots on each of the 1 by 1s. But let's count the 2 by 2. So let me pull this away. We would count on each flat level 1, 2, 3, 4, 5, 6, 7 toothpicks. So we do that 1, 2, 3 times, so that would be 21. 7 times 3 is 21. Then if we count the sides, we have 1, 2, 3, 4, 5, 6, and we do that for this level and this level, so that's 12. 21 and 12 is 33 toothpicks. And then if we count the dots, there's 1, 2, 3, 4, 5, 6 on each level. 6, 6, and 6 times 3 is 18. So we have 18 dots and 33 toothpicks. We add together the cubes on the end to make the structure complete. And we end up having a total of 57 toothpicks and 34 dots. So what do we do to go to a 3 by 3 by 3 example, or case 3? So let's take this away, and then let's again take our 3 by 3 by 3 case. Now before we even set up the structure, let's count it out, and then we can add it up later. So if we were to count this out on the top level, let's do dots first. We'd have 1, 2, 3, 4, 5, 6, 7, 8, and we have that 1, 2, 3, 4 times. So 8 times 4 is 32. We're going to have 32 dots here. Now, if we talk about the toothpicks, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the flat levels. So we'll have 10, 20, 30, and 40. And now we need to count the sides. 1, 2, 3, 4, 5, 6, 7, 8. And we do that on 1 level, 2 levels, 3 levels. So 8 times 3 is 24. So if you take the 24 on the sides and the 40 on each level, we'll have 64 toothpicks total. Okay, so now how does it look structurally? Well, again, it's layered. So if we look at this the way from the side, we would see it was layered with a 2 by 2 in front, and then a 1 by 1 in front of that. So we know that that's what it looks like from the side. However, if we turn this to look at it from the front, assuming the front is here, then we have to remember that it goes 12 that way and 12 this way for the case 12. So that means we've got to do the same thing for case 3. So we have it done on this side, now we have to do it also on this side. And again, if you look,
I was going to say, if you look for the layers, depending on which way you turn it, you can look at the different pictures and you can tell, now that you understand the structure, how which side you're looking at. And I hope you see now why it was important for me to explain the rectangle in the middle and then coming down on the sides, because that's exactly what happened. So for the question number 3, where it said, what directions would you give to LeWitt to build any particular case? My directions would be, depending on the number of the case, you would start with a rectangle with that number by that number. So in other words, if it's case 7, I would start with a 7 by 7 rectangle, and then on the 2 sides, a 6 by 6 rectangle on each side. Then on down, 5 by 5 on each side, 4 by 4 on each side, all the way down to the 1 on each side. Bring it on down. Okay, if you're talking about the total toothpicks and dots in case 3, because that was a question as well. So for the total toothpicks in case 3, if you take the time to go back in the video and add everything up, I'm not going to do it for you, but it's there. There are 154 toothpicks. And if you go back and add all the dots up in the 3 by 3, the 2 2 by 2s, and the 2 1 by 1s, you will see that there are 84 dots. All right, and you can build any case. You know, if you want to take this and also do a case 3 like I did, you can. If you want to get really ambitious and buy a whole lot of dots and toothpicks, you could try, I don't know, a case 5 or a case 8 or a case 4, whatever you want. The point is that you understand why it's built the way it's built, and then you have fun with it. You know, use the colors in different ways. That's where the art comes in. Get creative, where we can make the 2 match and just have beautiful things. Okay, with that said, I challenge you now. Go get some toothpicks and dots and build your own. Now that you've seen how it's done and you can see what it comes out, have fun with it. I'm going to stop my share now, and I'm going to tell you, I hope that you had a good time. I had a really good time building this and making the video. Shout out to my son for helping me with editing on the parts that it needed to go faster. I hope you have a beautiful day today. I hope you make connections. And as always, happy mathing.